Alright, so far we've looked at finding limits by two methods. What are those two methods? Graphically, numerically. We've done graphically and numerically. Okay, today we're looking at finding limits algebraically. Alright, so here's my limit. I want the limit as x approaches -3 of x squared plus 3x. And you need to remember back to last year, what was the number one rule when finding a limit? Plug it in.
Oh yeah.
The number one rule in finding a limit is plug it in. So make sure you always plug in before you start doing anything else with the limit. Okay? There are two problems that can happen when you plug in. What are those two problems? 0 in the denominator. 0 over 0. Very good, Jasmine. Nobody in last hour could get that. They got 0 at the bottom, but they didn't remember 0 over 0. Nice job.
That's an indeterminate form.
That is called indeterminate form. That is correct, Cole. Very good.
We're the best ones.
You guys are on top of it.
Surprise.
Yeah, she couldn't. She eventually got around to indeterminate, but couldn't remember what it meant. Okay, but so we are always going to plug in, and we are always happy with the answer we get, unless we get 0 over 0 or a number over 0. And we will talk about that later. We're not going to worry about that today. Okay, so on this problem, I want to find this limit, which means the first thing I should do is plug in. So if I plug in -3, that's going to give me 9 plus 9. And my limit is 18.
You have -3.
Sorry.
0.
Yes, it is. Thank you.
So we're not happy.
So I end up with 0. Justin says we're not happy. I say we're happy.
Yeah, that's good.
Because I don't have a number over 0, and I don't have 0 over 0. So since I didn't get a number over 0 or 0 over 0, we're happy with 0 being my limit. So what does that mean is going on?
And
Explain what that means.
crosses. No.
If I was looking at the graph, what's going on?
There's a hole there.
It's going like this and then it stops. Notice it's y equals 0.
You guys aren't getting what I'm wanting.
No, I don't.
What does the fact that this
Oh, you have a square root.
equals 0, and not just 0, whatever a limit would equal, what does that tell
An
me?
asymptote.
Quit getting hung up on the 0.
If the graph approaches the x value -3, the matching y value is 0.
Thank you. That's what I'm looking for. Okay? What this tells me is, as I'm headed towards -3, what y value am I headed towards? I'm headed towards the y value of 0. That's what this limit tells me. That's what I wanted you to get from it. So, that's what the first section is going to be. This first section from 5 to 22 is you're plugging in to find the limit. And you should not run into any problems. Okay, the next thing I want to look at are some properties of limits, of evaluating limits. Okay, now, when I'm dealing with a polynomial, what do we mean by a polynomial? What's the example of a polynomial?
X squared plus 2x plus 3.
There you go, x squared plus 2x plus 3. So we want to talk about finding the limit of a polynomial. It says if p is a polynomial, and this is really what we just said. It says if p is a polynomial and c is a real number, then if I'm going to find the limit as I approach c of p of x, it's going to give me p of c. What is this really telling me if I want to find the limit?
Plug it into that.
Plug it in. So this is, right here, this is the number one rule in finding a limit. It's just written down mathematically. You don't have to write this down. I just wanted to show you. Okay, so what this is saying is if you're dealing with a polynomial, just plug the value in, and that's going to be your answer unless you get 0 over 0 or a number over 0. Okay, this time we're talking about what do I have when I have a function on top of something else? What type of function is that called? When I have a polynomial over a polynomial. What's that called? What type of function?
don't have it.
You don't remember?
I'm trying to dig deep.
Starts with an R. It's a rational function.
Oh,
Okay.
it's on the board.
I've been trying to.
Alright, so it is when you're dealing with a rational function, you're doing the same thing, except obviously it says right here that my denominator cannot be 0. Alright, now this is where I really wanted to get to, the properties of the limits. And again, you don't have to write this down because everything we look at here is just common sense. What this is saying is the limit as I approach c of f of x equals L. So L represents the limit of this. So that means L is what type of value?
A real
What were you saying?
Y.
It's a y value. Remember, limits always equal y value.
Okay.
And then we have the limit as x approaches c of g of x. Its limit is k. So k is a y value. So I've got my two y values there. And we're going to do some manipulation with these two functions. On this one, they're saying that b is a constant coefficient. So if I know that the limit of f of x is L, and then I stick a constant coefficient on there, what do I have to do to get my limit? What is this telling me I need to do to get my limit? Multiply by the coefficient. That's all this one's saying. That should make sense. Okay, this one's saying that if I know these two limits, and now I want to take the limit of those two functions added together, all that's saying is, what do I have to do to find my limit?
Yeah,
Add the limits together, yes. This one's saying if I want to take the limit of the two functions multiplied, what do I have to do?
multiply.
Multiply the limits together. This one's saying if I'm dividing, what do?
You divide them.
Divide the limits. And obviously my denominator, again, can't be 0. Okay, so that all makes sense.
System letters.
This one is saying that if I know a limit, and then I want to take the limit with an exponent, all I have to do is what?
Take that
Raise it
limit
to
with
that
the
exponent.
exponent.
Right, raise it to that exponent. That's all that's saying. Alright, so back on this sheet, let's look at 37. Look at 37. It's saying the limit as x approaches c of f of x is 3, and the limit as x approaches c of g of x is 2. So on A, what's the limit as x approaches c of 5 times g of x?
10.
10. What about B?
5.
5. What about C? 6. What about D?
3 halves.
3 over 2. Very good. Look at 39. Part A.
27. Wait, what is that?
48.
56.
64.
64.
64. Part B. 2. Part C.
12.
12. And part D.
Oh, crap.
2, wait, 4, 2, 3, then 4.
32.
I'm gonna type it
No, don't cheat with the calculator. Do it in your head.
Radical 4
out. Is it 8?
How'd you get 8?
Yes.
I took the square root of 4 because the 2, and then I took a 2 to the third.
That's correct. Take the square root. The bottom number of the fraction tells you what root to take. The top number of the fraction tells you what power to raise it. So the square root of 4 gave me 2. 2 to the third gave me 8. Any questions on that? Okay, the next thing we need to look at is the composition. Find the limit of composition of functions. So, for instance, what do I mean by composition? What am I talking about?
7. The equation.
The limit itself.
No. This is what I mean by composition. Okay, so now what do I mean by composition?
The function
Where is g of x located?
within.
Within inside of f of x. So when I have one function inside of another function, that's what we're talking about composition of functions. Okay? When they are kind of nested inside of each other. Okay, so what it tells me is if I want to take the limit of a composition of functions, this is what it tells me to do. And then I want you to explain what it's telling me. Okay, they're saying that those two things are equal to each other. So what is it telling me to do if I want to find the limit of a composition of functions?
That you're going to plug the limit within the function. No.
Take that out.
What is that part telling me to do? Find the limit of g of x, and once I find the limit of g of x, what do?
Plug it.
I plug it into the function f. That's what it tells me to do. So you're going to find the limit of the inside function, and then take that limit and plug it into the outside function. That's what it wants me to do. So let's look at 23.
So that means that's just two ways to write that. Pretty much, if they're equal.
Yeah, these are one and the same. Yes.
Okay.
But what we're doing is we're trying to show you how to handle something like this,
Something within something.
and understanding that we're finding the limit of the inside function, and then plugging that limit into the outside function. That's what's going on there.
It's like on part C of 23, you move like the G out and then solve for the f of x for that limit and then put that back.
Correct. All right. So on 23, let's do each part. What is part A? Part A is 4. What would part B be? 64. Okay. Now, what do I have to do to get part C?
You put
You got,
G and then in parentheses 5 minus. You do x cubed in parentheses and 5 minus it.
All right. You're taking it a little bit too far. I want you to do it. Talk to me in terms of what this thing is telling me to do. I want you to get technical on me. What does it want me to do on part C?
Find f of x.
No, that's not technical enough. What does it want me to do?
find the two
Plug f of x and then
limits
g
of
of x.
each and then multiply them.
Nope.
This is basic.
On part C, what do I have to do first?
As x approaches 1 of f of x.
Nope. You were close.
Strategically place
I'm almost.
line into it.
You're almost there. What do I have to do? Oh, did you say f of x?
Yeah.
Yes, you're right. All right, first thing it wants me to do on part C is find the limit as x approaches 1 of f of x. That is correct. And what is the limit as x approaches 1 of f of x? 4. Okay. Once I figure out what that limit is, what do they want me to do with 4?
Plug it into it. We'll find the limit of g of x.
No, it doesn't want me to find the limit. This thing doesn't want me to find the limit. What does it want me to do? Once I find the limit of the first one, what do?
Plug it
Plug
in.
it
I
into
plug it into the second one. I'm not finding the limit of the second one. I'm plugging it into the second one. So once I find the limit as x approaches 1 of f of x is 4, what am I doing with 4?
Plug it in.
Plug it in.
Plugging it into g. And when I plug 4 into g, what do I get?
64.
64. So that's what you do on compositions.
This is 5, right?
Yes. Here we go. Moving on.
What if you break it?
All right. Then the last section we need to talk about is 27 through 36. We're finding limits with trig functions. And again, whenever I'm finding a limit, what should I always do? I should always plug in first. So on 27, if I want the limit as x approaches pi over 2 of sine of x, the first thing I do is
plug in pi over 2.
plug in pi over 2. So then I need to evaluate sine at pi over 2. And
One.
yes, I've given you some nice stuff on the board already.
1.
And sine of pi over 2 is 1. So my answer would be 1. Okay. Any questions? All right, we're doing 6 to 40 even is what you're working. And do not throw this away. We will work more on this later. So don't throw this away. 6 through 40 even.
You can kind of break the first 6 through 22.
What?
Or 6 through 22 really easy.
They are. But what I want you to do on 6 through 32, the minimum that you have to do, like on 6, you have to write down the limit as x approaches -2 of x to the 4th, and then you can give me 16. That's the minimum you've got to write down. I want you to write the limit down, and then tell me what the limit equals. I don't want you to